All right, guys, we're going to draw a couple of Lewis structures here. The first one we're going to do is OF2. First thing we need to do is calculate the number of valence electrons in this structure. We get that from the group number. Oxygen's in group 6, and each fluorine is in group 7. All right, so we have 14 plus 6, so this structure is going to have 20 valence electrons. So our final structure has to have 20 valence electrons. The next thing that we want to do is we are going to start by connecting the central atom, which is oxygen, with a single bond to each of our fluorines. All right, that uses 4 electrons, right, because there's 2 electrons in every bond. All right, so I've used 4, right, which means I have 16 more electrons that I need to place. I'm going to start by putting them on the outer atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That gives both of those an octet, and then I'm going to add 13, 14, 15, 16 on OF2. So this structure has 16 electrons, and then I can check to make sure that each of my atoms have an octet. All right, fluorine has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. And fluorine has 2, 2, 4, 6, 8. All right, so this structure now has 20 valence electrons total. All right, and everyone has an octet. So it's good. This molecule is bent, all right, because it has 2 bonds and 2 lone pairs. And it's going to be polar, all right, because there's lone pairs on the central atom. The next structure is PF3. We're going to do the same thing by starting by calculating our valence electrons. Phosphorus is in group 5. And we have 3 fluorines, each in group 7. So this structure is going to have 26 electrons. I'm going to start by putting phosphorus in the middle. I'm going to connect my 3 fluorines. I've used 6 electrons in this structure. So I have 20 left that I need to place. I'm going to start on the outer atoms. 2, 4, 6, 8, 10, 12, 14, 16, 18. And then I'm going to put my last set on phosphorus in the middle. So now I go back and check to make sure that I have 26 electrons and that everyone has an octet. All right, so if I start counting 2, I'm going to use a different color to kind of count here a little bit. I'm going to use this green. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 electrons. So that's good. And now if I look, does everyone have 8? This fluorine has 2, 4, 6, 8. This fluorine, each of the fluorines is the same, so they have 8. So let's check on the phosphorus. 2, 4, 6, and 8. So everyone has an octet. So I'll redraw that structure real quick. P, F, F. All right, and that structure would be PF3. This is trigonal, pyramidal. All right, and it's going to be polar because of that lone pair of electrons on the central atom. All right, so let's look at 2 that have that are going to have double bonds. So we're going to look at carbon disulfide to start with. Oh gosh. I'll have you guys teach me how to use this. CS2. All right, so carbon has 4 electrons. Each sulfur has 6. All right, so 12 plus 4 is 16 electrons. We're going to put carbon in the middle. We're going to start by drawing a single bond to each sulfur. We've used 4 electrons. So we have 12 electrons left to place. We're going to start by putting them on the outer atoms. 1, 2, 3, 4, 5, 6. That gives sulfur an octet. 1, 2, 3, 4, 5, 6. So I've placed my 12 electrons and I've given each sulfur an octet. All right, so this structure has 12 not 12 electrons. It has a total of 16 electrons, sorry. The problem is that carbon does not have an octet. Or 8 electrons around it. We can't just add electrons because we have 16 electrons in our structure, and that's how many we have to have. So in order to give carbon octet, all right, it only has 4, so it needs 4 more electrons. I'm going to dump 2 electrons from this sulfur in, and I'm going to dump 2 electrons from this sulfur in. So all I'm doing is moving that lone pair of electrons, and now, instead of it being a lone pair, it's going to share with carbon. So this structure now, you'll notice carbon has 2, 4, 6, 8, because I'm counting these 2 bonds with carbon, all right? So it has 8 electrons. All right, this sulfur has 8 electrons, 2, 4, 6, 8, and this sulfur has 8 electrons. All right, so everyone has their octet. And then if we count up our structure, we still only have 16 electrons in there. We have 2, 4, 6, 8 that are lone pairs, the dots, and then 2, 4, 6, 8 that are in double bonds. So this molecule now is carbon in the middle, 2 double bonds to sulfur. This molecule is linear, okay, because it only has 2 double bonds and no lone pairs on the central atom. And this molecule is going to be nonpolar. Each of these bonds is polar. Sulfur pulls the electrons more tightly, but they cancel each other out, and the overall molecule is nonpolar. Okay, let's look at one more example where we have a double bond. I'm going to look at NOF. All right, so NOF, I know that nitrogen is the central atom, so I would need to tell you guys that. All right, so we're going to add our valence electrons. 5 plus 6 plus 7. So that's 11 plus 7 is 18 electrons. Nitrogen goes in the middle. Oxygen goes on one side. Fluorine goes on the other. All right, so I've used 4 electrons. All right, so I have 14 left to go. All right, so I'm going to start on the outer atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so I placed my 14 extra electrons. So this total structure has 18 electrons. The problem is that nitrogen doesn't have 8. I apologize. I'm trying out my knockoff Apple Pencil. I forgot my cords from my other tablet, so I'm doing my best here. All right, so what we need to do then, again, is we need to dump those electrons to make a double bond. Now, I know that oxygen prefers to double bond versus fluorine. If you guys didn't know that, I would not take off points for that in this course. Okay, so I'm going to dump these electrons on oxygen into nitrogen, all right, because it has 6, so it only needs 2 more electrons. So that's going to give it 2 more electrons, all right, and I'm going to leave my 2 lone pairs now on oxygen, and I'm going to leave fluorine alone. So now this structure should have 18 electrons, all right, and everyone should have an octet. 2, 4, 6, 8. Oops, I forgot the lone pair on nitrogen, my bad. There should definitely be a lone pair there. All right, and then nitrogen has 2, 4, 6 from bonds and a lone pair, which gives it 8, and fluorine has 6 from lone pairs and 1 from a bond, which gives it 8. So this final structure is going to look like this. And this molecule is also bent. And it's also going to be polar because there's a lone pair on the central atom. So anytime we have a lone pair on the central atom, we have a polar molecule. Okay, hope that helps. Happy studying. See you tomorrow.